Yeah, okay. Hello, everyone, and welcome to the OCP security track. This is the first session of the security track, so we hope you'll be attending all of our sessions, and welcome. I'll say one thing about the track, and then we'll start diving into the session. Many of the sessions in the track have been designed to be open discussions and allow interaction. So we can do interaction through the chat window, or you can also click the join button and join us voice if you want to, have a lively discussion and be able to speak with us. We'd be welcoming that. So with that said, let's get started with our session today. This is a session around security project alignment. We have several speakers here with me today, and even one new one, I think. So we have Nate from Google, myself from Chameleon. We have Shiva from HP who talk about Tcg effort, and Jeff, and I think Brett may be here as well to talk about Dmtf, and Rob Spager from Microsoft. I guess we'll do the introduction every time when we move to the slides. The purpose of this session is really, as we've been defining the specs for root of trust for open compute security, it's pretty clear that there are several projects in the industry that are working in similar initiatives or in the same area. And we thought it would make sense to have a talk on how we align between the security initiatives, identify where we may be doing some things that could benefit from better synergies, sync on approaches. So this is really a discussion between those different initiatives and projects, how to do a good job at coordinating them and align them and basically drive for minimum overlap and maximum synergy. That's what we want to get out of it. So in order to facilitate that discussion, we have guests from all of the relevant projects. And we'll start by some presentation or introduction on the approach taken by each of them. And then we'll open it up to a comparison discussion. Basically, we want to hear the community's voice on what can we do better and how to make those requirements or the different projects align better. So let's get started. I'll start with the open compute security model. I guess many of you are already familiar with that, and it's just like a recap of how we think about the threat model for OCP security. So basically, the idea here is to protect firmware against all kinds of threats, right? And the model that the OCP group has taken is to define this root of trust component, which can be a PA root of trust, a platform active root of trust. That's the root of trust on the platform or on the motherboard, the one that protects the CPU and the BMCs. And then there could be a root of trust on every peripheral, think of it as PCIe cards, SSDs, etc. Each of them also needs to have a root of trust. And the root of trust parts are basically, think of it as you have to start from some mutable code and put the system up in a secure way, verifying signatures, and then an attestation that happens between the components and the platform to verify that all peripherals in the system are have booted healthy and with the right firmware. The OCP security focus has been on defining the secure boot and identity spec for how a root of trust needs to behave, an attestation spec that focuses on how the attestation between a platform and a peripheral works. And obviously the same root of trust, that same requirements around secure boot that happens in the active component or in the peripheral also apply on the platform level for the root of trust secure boot. There is a deeper session from previous summit. You have the link here if you want to follow up later that talks in more details about it. And also, if you look at the Open Compute blog, we just released a blog this week because we've announced the V1 of the 3 Open Compute specs availability. And if you go to the opencompute.org/blog, you'll find there more details about every spec and where it belongs. Now, when we talk about threats, in the OCP, we've divided threats to threats that involve attackers with logical access, physical access, some assumptions, and some out of scopes. The general theme here is that we are protecting against firmware persistency threats. There is a list of the different threats in one of the OCP deliverable, which is the threat scope document. And you can find the things like the risk of execution of unauthorized firmware, execution of authorized firmware, but with defects through, for example, rollback attacks, compromising the keys for the firmware, having firmware that is unpatched and has known vulnerabilities, and how do we deal with it, etc. So I wouldn't go through the list, but the idea here is that there are threats that can basically compromise the firmware when an attacker only has logical access. Then if attackers have physical access, there is another level of threat, right? You can use the physical access to go after some public interfaces, or you can modify the flash on the flash component. We deal with those again through these specs for secure boot attestation. There is a spec in the works for secure updates and recovery, and there is a document for best practices of how to develop secure firmware. And if you look at the threats doc, it basically maps each of the threats here to one of the features in the specs that we have defined. We also made some assumption around what is expected. So for example, because we are dealing with data center security, there are some assumptions around some level of physical security around the server. There is an assumption for a secure provisioning for the initial provisioning of identity for the root of trust. Those are, again, documented in the threats model. And out of scope for me is always opportunities for the next time, right? So we didn't do a complete end-to-end supply chain management threat model yet. We've started with the let's protect the firmware, but obviously there are opportunities to do to go and dive into additional areas and cover them with additional context. So that's kind of like the high level of OCP. So again, the model is firmware threats, and the approach is root of trust on every component. With that said, let's start understanding the other security initiatives and the other approaches, and then we can go come back to the discussion about alignment and how it changes. So for the Dmtf approach, is Brett here or is Jeff going to present it? I think it's Jeff, right?
I'm here.
Brett, hello. Okay, I see you now. So hi. Brett will present the Dmtf, and you have the stage.
Okay, thanks, Yigal. Go ahead and go to the next slide. So what we're presenting here, that this is a set of information that's a snapshot of where Dmtf is now and work in progress within Dmtf. Some of the information that we're showing is related to existing standards that have been released. Some is a forward look at ideas that are under consideration for future work. So with that being said, go ahead and go to the next one. So Dmtf's focus has been on enabling, really enabling all the things that Yigal was discussing at the protocol level. So putting together a protocol and a set of messages that can be exchanged between the endpoints that Yigal was speaking about. The focus is very much at the message and protocol level, and enabling that piece and leaving policy to other parts of the ecosystem. On this slide, we're showing some of the SPDM 1.0 and 1.1 features. These are all features that have been released. So in 1.0, there is support for certificate chain retrieval and challenge based on those certificate chains, and then an ability to report measurements. This is all captured in what we call MCTP type 5 messages. For SPDM 1.1, there were a number of feature add-ons, primarily in the area of encryption and authenticated messages. This includes the ability to set up a session and exchange keys, as well as manage the session. And these are captured in MCTP type 6 messages. The next slide is going to get into some more detail on the difference between those two message types. But this is really the overview of what the two message types can do. And then a note that we wanted to put in here is that Dmtf is working with a number of industry partners to try to align on a single protocol. And that's been an important piece of work that Dmtf has taken on, is really trying to get the industry to gel around one protocol for security, no matter what the transport is. And so Dmtf has been working with, you see the list here. It's been working with the PCI SIG, MIPI, obviously OCP as we're here today, CXL and Gen Z, and HD base T. And there's also work underway with JDEC. So go ahead and go to the next one. So this slide just shows an overview of how the different message types fit together. And the goal of this slide is to show how SPDM fits in with existing protocols that are in use in pretty much servers all over the place. Starting at the bottom, servers today use MCTP for most of their management tasks. And that can be between a platform root of trust and a device, or between a management controller and a device. So SPDM wanted to leverage that existing framework and build on top of it. On the left side is what I referred to as message type 5. So message type 5 is used to take measurements, perform authentication, and really perform a lot of the certificate and challenge commands that are discussed in the OCP attestation spec. It's also used to set up a session. And once the keys are established for that secure session, it can move over to the right side of the diagram. And on the right side of the diagram, there's a layering of the different protocols that enable an encapsulated encrypted message. And these can be used not only for security mechanisms, but they can be extended to other message types. So they can be extended to PLDM, RDE type messages, and even to vendor defined messages. So the goal of this layering is really to allow us to use security in a number of different realms. Go ahead and go to the next slide. Now, in this slide, we wanted to give an overview of features that Dmtf is considering for the next version of SPDM. Just the disclaimer is these are all under consideration, but there's not a committed work list yet. The first thing that's under consideration is a command to set certificates. So the goal of this command is to allow an endpoint to manage the certificates that are in the different slots. And when you go through the OCP attestation spec, you do see references to loading in additional certificates. Set certificate, if it's in 1.2, would play an important role in that. Dmtf is also looking at eventing, and really there are situations coming where it makes sense to tell a listener, like a PA root of trust, that something has happened, and this could be an endpoint has reset or firmware has been updated. That's the type of thing that's under consideration for eventing. Multi-tier authentication is also under consideration. This is a mechanism that's intended to let a PA root of trust find out information about devices that are behind a non-transparent bridge. That could be through some mechanism that crosses that non-transparent bridge, but the idea is to make those devices visible and authenticatable. The next one under consideration is a smaller certificate. We are looking at ways to shrink the certificate from an X509 to something smaller, and I know that's been openly discussed in OCP about, there's been discussion of ways to do that. The next item is a measurement manifest. And this is just giving a way to provide measurements that would conform to a manifest of what the expected measurements are. The next item is support for Tcg Dice. And this would be extending the ability of the certificate framework within Spdm to handle Dice style certificates. And I know Dice certificates are referenced in the OCP attestation spec. And so adding on support for them would help move towards, would help align with the OCP spec. And then the group is also considering reprovisioning. And this could be reprovisioning of device keys or some way of invalidating device keys on an existing endpoint. So Jeff, did you have anything else you want to add to this?
No, not particularly, other than a lot of the work that's going on is, you saw a lot of the pictures were MCTP specific, which probably if you were in the hardware management sessions on Tuesday, you saw a lot of the work that's going on with OCP hardware management around PMCI and that set of suites. And so the stack picture you were looking at discussed a lot of that. But just want to emphasize the point of Spdm itself is a leverageable protocol that's not tied to MCTP specifically. And that was kind of the big point with the alliance partners. So it really was meant to be generally usable by other protocols. So like when CXL came along or Gen Z came along, it was easy for them to adopt. And HD-Base-T was one of those standards bodies that just kind of came out of the woodwork and said, hey, can we use it? So there's a lot of support behind it in the industry. And this set, you know, when we get into the discussion period, boy, if there's anything else you want to see in a future version, these won't necessarily be in 1.2, but it's all a list of stuff we're looking at, plus some other stuff that's not on this list. Other than that, I think you did a great job, Brett.
Okay, thanks.
Thank you. And I'll say something. I think that within OCP, when we've been defining data station spec, it's pretty much built as a layer on top of Spdm, or at least that's one option that is allowed, right? So it's leveraging the Spdm capabilities and just like adding on top of that some layers. So I personally see good synergies there, but we'll get to the discussions and see if other people see it differently. So with that said, let's talk about the Tcg Sci-Res. And for that, we have Rob here from Microsoft. Rob, your stage.
Thank you very much. I'm one of the co-chairs on TCG's Cyber Resilient Technologies Work Group. And you know, it's very encouraging to see the use of TPM and Dice and the other work that's going on that was presented today. So that's excellent. What the Sci-Res work group in TCG is looking at is how to implement recovery and resilience for systems. And it builds off of the roots of trust like Dice or TPM. Those are tools to be able to figure out if recovery needs to happen. But it really could be a layered approach where a very low level does recovery for a subsequent component in the boot process, and then that does recovery for another component of the boot process. So you might have a very layered architecture. So we haven't tied our resiliency to a precise root of trust. Instead, we're talking about a relationship between different components involved in doing recovery. And for that, we've kind of defined three different entities that are important. The first is the resilience target. It's the thing that's mutable, that may need to be recovered if something has gone wrong. Maybe it's been compromised by malware, maybe some of its critical information is corrupt and it needs to be repaired. Something that's causing it not to function or to be incorrect may exist, and it could be corrected because it's mutable. And then the other piece in this relationship we've defined is the resilience engine. It's the component that's going to be able to be invoked when there is a need to fix the target. It basically does those recovery activities. And it needs to have a way to do those, even if the target has been compromised by malware and doesn't want to participate in that recovery process. So it needs to have a way to execute all by itself in a secure environment that the target isn't able to tamper with. It needs to have an ability to modify the target, maybe for its firmware configuration, maybe for its software. Whatever component of the target needs to be repaired, the engine needs to have a way to be able to do that. So we're expecting the engine to be local on the same device as the target to reach into it and do those repairs. And it also needs a way to protect itself from the target. Maybe it has its own backup image or storage or configuration. Those need to be protected from the target in case the target is compromised, so recovery can still happen by the engine correctly. And then finally, we have put a whole bunch of other stuff that decides when recovery needs to happen into something we're calling the resilience authority. Now, if you think about how you do resilience for solutions today, you might be patching proactively. You might know that a compromise exists in the wild and have corrective steps to remove it from infected devices. You might be trying to do detection and do investigation and response when failures occur in something that you're relying on. All of those things could involve processes, organizations, could involve manufacturers signing code so it can be installed in a device that's in a way that's compliant with its secure update mechanisms. All of those things we've just encapsulated into something we've called the resilience authority. It could involve, an organization's IT department and the manufacturer. In a consumer scenario, it could just be the manufacturer pushing out updates or removing infections. There's a lot of complexity that goes into deciding when recovery should happen or when patches should be installed, and kind of the gateway for servicing to happen. That's all been abstracted in our model into the resilience authority. So using these three components, we started to look at what building blocks could help in this relationship to be able to do resilience for devices. And this is really a new line of work for TCG. And I think it was driven initially by NIST 800-193, which looked at resilience for platform firmware. And this is kind of TCG exploring how to implement those things in ways that use TCG technologies. So if you could go to the next slide, please. I'd like to talk about some of the building blocks we're looking to add into TCG's kind of arsenal of tools to be able to improve security. The kind of three main things the Cyber Resilient Technologies Workgroup is focused on is how do we create a safe place to stand for the resilience engine so it can do recovery even if the target's infected. And so we've kind of named this a secure execution environment, which we don't think has an existing formal definition in the industry. But for TCG, we've looked at just one narrow case for how to do this in systems. And that narrow case is, let's assume the resilience engine and resilience target may share the same hardware resources. If you reset a platform or a part of a platform, and you let the resilience engine run before the resilience target has started, then it may have a clean environment to be able to do recovery that isn't able to be interfered with if the target has malware in it or is trying to prevent that recovery action from happening. So we've kind of carved out a very narrow slice of how to do recovery to figure out an end-to-end specification that we could publish to look at how to solve some of this recovery problem. And that we know there are other ways you might be able to do recovery. You might have a resilience engine that is able to do recovery steps while a target is running. For now, though, for our first specification, which should be published in the next couple days, we've looked specifically at if you do a reset of a module, have the resilience engine start before the target, it can run without interference from it if it has a secure execution environment to do that in. The other thing we wanted to provide is a way for the resilience engine to protect its configuration and storage information from the target. And for that, we've defined protection latches. You may be familiar with self-encrypting drives from TCG where they have bands that are locked and you have to provide an authentication code to unlock them. The protection latches we've defined for helping to provide resilience actually function in the opposite way. They start out unprotected, and then you can flip this switch and they'll be protected until there's a reset that occurs. What this does is if you have a resilience engine that gets control first, which is the way our model works in the current specification, it can do activities it needs to, like writing and reading of storage that's protected by the latch. And then when it's ready to transition to the resilience target, which is less trusted, it can turn on the write and read protections and prevent the target from accessing those until a reset occurs. Because the resilience engine gets control after the reset before the target, it can turn on those protections again. So it's a little different model for how to protect storage in that it's open initially, and then it gets protections turned on before you want to do something that may be risky or less trusted, like executing a resilience target or transferring control to it. And then the other problem we had to solve was the resilience engine is going to get control first after a reset, so it can do recovery. But what's going to cause a reset to happen so the resilience engine can get that control? And what we focused on is something we originally called Watchdog Timers, but now we're calling Watchdog Counters. And the intent of those is to have a building block where you can configure it so it will reset the platform or the module so the resilience engine gains control. So, a very simple example of this in the industry today is a Watchdog timer that, you turn it on, and if some other sequence of steps don't complete and turn it off later, it would reset a platform. It's good for stability. If you've got some, a process you're going to go through that doesn't always work for some reason, it could reset the platform and get you back into a stable state. It's not resistant to malware, though. Malware might just turn off a Watchdog timer that exists today. So what we've defined is a latchable Watchdog timer. And I think I've got one more slide on this. If you want to go forward, I got a little more detail on this. Oh, okay, go back. I don't have another slide on this. But basically, the latchable Watchdog timer is designed so the resilience engine can turn it on after it configures it for a certain time period. So the resilience engine gets control first during boot. It configures a Watchdog timer to maybe restart in a day, and then it lets the resilience target run. The resilience target can't turn off the latchable Watchdog timer, so it will be terminated after 24 hours and the platform will recycle. This could be a problem for some devices, so we also define an authenticated Watchdog counter where there is a way to get a ticket so the resilience target can provide that ticket to the counter and be able to run for longer. So if you have some other entity like a resilience authority that the target can do attestation to, and the resilience authority has information about if there's an infection for those targets or not, it can decide that the target can keep running so you don't have a service interruption on the device. It can provide back a ticket for keeping the target running for another 24 hours or 6 hours or whatever time frame you want that target to have to check in with the resilience authority. And then the final piece of this we've looked at is, what if you've got a resilience target that wants to put the device into a low power state? In a low power state, the latchable watchdog timer may not be functioning. In that case, we've kind of required that those things are able to function in whatever low power states the target might put the device in. So this is kind of the foundational work we've been trying to do around resilience. And you know, if you look for in the next couple of days, TCG should have a cyber resilient module and building block specification published. And this is really the beginning piece of TCG carving out a little piece of how to look at resilience and building blocks that are going to support that. So that's what I wanted to cover today. So thank you very much.
Okay. Before we move on to Shiva and TCG Server Group, just a quick question: Do you see the work you're doing as a like architectural model or as a spec for how to implement, or some combination?
I think what we've tried to do in this case is carve out a narrow case of how to do resiliency for early boot as a safe place for the resilience engine to stand. It's an architectural model. It's got some foundational definitions. It also has normative requirements for some building blocks that would be needed to make this solution work. We do expect, though, that in different platform types, there are going to be different requirements associated with exactly how to implement this. We try to do this in an abstract way in TCG's Cyber Resilient Technologies work group, and you might see more specific platform guidance come out later from TCG in the future, depending on how, you know, a specific implementation might have best practices or even normative recommendations about how to apply this architecture.
Thank you, Rob. Okay, so Shiva, you have the stage now.
Thank you. I'm Shiva Desari. I chair the Tcg Server Group. As you can see here, the purpose of Server Group is to provide specifications and guidelines, requirements for implementation of TCG technologies in servers. Let's go to the next page. So what I will be covering today is some of the activities or the specifications that TCG has published for public review recently. And that doesn't mean that that is only the work TCG Server Group is doing. There is other work going on, but unfortunately, I won't be able to share those details today. Hopefully some point later, I'll be able to talk more. But let's go with what we have here. One of the most recent work TCG Server Group has been working on. Some of the companies represented here are part of that effort, is building a specification for server management domain firmware profile. In other words, if somebody wants to connect a TPM to BMC, for example, this specification provides the requirements to satisfy so that external attestation entities or the verifiers can verify the TPM measurements in a consistent manner. Attempt here is to standardize what measurements goes to which PCR, so that when verifier goes and tries to grab those PCRs, they know what the mapping is. This is not anything completely new. We leveraged existing spec on the host side. Currently, there is already a spec available, which measurement goes, what PCR kind of definition, along with a bunch of other things, what kind of firmware needs to be measured, when. All of those are documented in the form of platform firmware profile specification. So we leverage that spec and sort of repurpose that to the TPM that is connected to BMCs, because environment is a little bit different here. On the host side, UEFI uses the TPM until it passes control to operating system. Once it passes control to the operating system starts using it. Whereas on the management controllers such as BMCs, pretty much entire of the code stack can use this TPM, and it's mostly vendor or some cases, if you take OpenBMC kind of entities into account, could be the consumer. Architecture doesn't prevent any of those, but as you can see on the right side here, the very simple mapping of PCRs to the typical code stack that runs on BMCs. We also specify some of the behavior related to what should happen when various power states are transition from one state to the other state. And this document completed public review a month or two ago, and it will be published soon as a final document. Can you go to the next slide, please? One thing I forgot to mention, I wanted to refer back to Eagle, your first slide, where you sort of put in TPM and platform root of trust, and TPM is the one used for attestation. I think this one can fit into that use case very well. So external entities could attest BMCs using this TPM.
Do you envision a separate TPM for the BMC, or one that serves the CPU and the BMC together?
So currently, architecturally, I think there are some difficulties in using same TPM for the host and BMC because of the power domains and the way those two hardware and firmware behave. So if you strictly follow TCG platform firmware guideline, it may not allow you to put BMC's measurements into that because of some sequencing issues and other things. Typically, BMC comes up even before TPM comes to life, because TPM is accessed through CPU, and the CPU comes to life after BMC comes up. So there are some practical issues that are currently forcing to have two separate TPM. Server group looked into this and spent a lot of time, finally concluded that I think the simplest way to address this issue is to treat these two domains as separate domains and have separate specifications so that things are clean. But I think it is probably possible to come up with some creative way to use single TPM for both of these use cases. But at this point, I don't know any way to do that without breaking the requirements that we have currently.
Yeah, thank you.
There are other specifications or active work going on in multiple areas. Server group and PC client work group within TCG. We work together and share some of the documents. For example, here you see TCG ACPI specification, which is delivered by server work group, but PC client work group also uses it. And similarly, for example, third one, PC client specific platform firmware profile specification documents how to handle TPMs that are on the host side. Server work group or servers in general leverage that spec. And similarly, the TPM that we use on the management domain is same as what PC client specifies in the bullet 4 here. And all of these documents are available publicly. If any of you interested to look into more, you can get to those documents. This is just an idea to indicate what kind of work going on between PC client and server, and that is already publicly available and can be shared with the broader team. I think there was one other slide. Oh, that's it. Okay. I'll be glad to answer any questions, comments.
So I think at this time, I've taken many notes here, but I would like to start involving the audience as much as possible. So any thoughts, questions from the audience, thoughts about where alignment is worth pursuing? What do you think? And Nate, you've been quiet, so maybe you want to say something about your impressions so far. Anything from the audience?
There currently aren't any questions in the chat. So if you are on the session, feel free to click the Join Now button and you can gain speaker access. I will let you in and unmute you so you can ask the question live, or you can type your questions or comments in the chat box. Currently, there are no questions.
Okay.
So I've got a question. When we went through the Dmtf's Spdm 1.2 list, what on that list is a priority for OCP? In other words, if it takes us forever to hit everything on the list, are you willing to wait a year for another spec, or do you want something in 6 months with a subset of those features, or what do you see the industry need to be?
One of the things that we've been looking at a lot is smaller certificates, especially for if you want to bring in like IoT devices and things like that. Trying to handle large certificates is just impossible.
So what's your definition of a smaller certificate? A compressed X509, a binary version, or a new format?
Just compressing it, I don't think helps, because you still have to be able to parse a full X509, and then you also have to add compression and decompression on top of that. So I feel like you've made it more resource intensive then, not less. So a binary format would be great, and something that doesn't require any kind of string parsing. So we can basically limiting the the number of different libraries you'd have to include for a very small device to be able to use it.
There's another standard that was established for smart cards and global platform called card verifiable certificates. Those are pretty small and easy to parse. It doesn't say we've standardized on them, but they exist and they are already a standard.
So that's my preference, is to find something that already exists and is a standard. I don't know. I don't see Dmtf as being the body to develop a new certificate format. So, if you have some more specific requirements of what you need and there's a way to publish that, that would help us a lot.
I was also going to say on top of smaller certificate, which comes up often in the OCP call, I think the eventing here sounds interesting as a way for a root of trust to communicate security events, security alerts out. So when something goes wrong, it would probably be great if there was a layer in the protocol that allows outbound communications about.
Yeah, I can get really geeky on the eventing issue. I don't have an answer, and I'm not going to discuss where the group is going, but in the whole PMCI protocol stack list, we chose Spdm to go over MCTP for a variety of reasons. We didn't choose PLDM. Maybe we could do that as an alternative. I'm just speculating, but MCTP has no eventing mechanism. PLDM does. So, we could have leveraged existing code for an eventing mechanism. That I look at as a problem. It's really kind of a manageability Dmtf problem. When it comes to eventing and possible proposals is that something you see as a generic security issue, or is that something that's more transport specific? Because as I start thinking through it in my head, it seems to be a transport issue, right? The back channel communication is going to be different for a PCI than it is for a I2C, I3C, or versus a whatever other kind of topology. So, what are you thinking there?
Yeah. Oh, it's a good question. I'm trying to build a mental model in my head. I think what I was referring to is that at the end of the day, there is a PAROT that needs to be kind of like in charge of the platform, right? And there is the channel from that to report outside to the management fabric. But you also need the channel within the system to report, let's say, a peripheral has discovered some security issue, and you need to report, I would expect, to the PAROT. So maybe it's two different solutions. I'm not sure, but I was looking at that and I was thinking this is an area where we haven't spent enough time defining how it needs to work in a standard way.
How would it send non-security related events now? Surely it has to do that, no?
I mean, the platform does right now. So if you look at the suite of specs from the DMTF, there's two different sets, right? Well, there's a whole bunch. Two for this particular problem space that are relevant right now. One's the PMCI set of specs, which is infrastructure inside the infrastructure communication, where we've mapped to I2C, and if you look at the session that was done Tuesday on PMCI, I'd encourage you to go back and look at that. So that includes eventing inside the infrastructure. Eventually it gets to the BMC, and then you go to Redfish for stuff to communicate, start going communicating outside the box. So inside the box, we've got Redfish device enablement, but the security stuff can map to Redfish objects as well. And then we may not have events specifically the kind you're looking for. If we don't submit feedback to the DMTF or talk to one of your reps, we can put them in the registry. It's super simple. I mean, we turn that spec 3 to 4 times a year just to keep it as relevant as we can. So if you have needs in that area, just let us know.
Can we talk about Cyrus for a moment? Because I was thinking and trying to map in my head what OCP is doing and Cyrus model. If I go to the slide here, I kind of think that there is a mapping between the resilience target is like the flash we're trying to protect, and the engine is our ROT, and the authority is what we've been calling the owner or the holder of the dev update key, whatever. Is that how you would map it, or what's your thinking on the mapping between OCP and Cyrus?
I think that would work. You could also have that relationship a little farther up as well for, even this model could be applied to, for example, the OS and applications, right? It may not use those building blocks that would be provided at the hardware level to protect the OS from applications, but the same model can be applied at many different layers in the boot process or the components in a system. So it'd be great to have feedback, especially during our public review period for the specification on how different people or organizations might be able to use this. This is really, TCG's first try at how to do resilience. So getting feedback would be helpful. We've done stuff around recovery or, AB updates or things like that in the past, but this is kind of our first specification from the Cyrus work group. So I'd love to hear how well this model applies for the OCP scenario that you mentioned.
Yeah, that's what I'm asking. I think because this session is meant to explore for where can we do better in alignment and discussions. I think that mapping OCP to Cyrus would be a helpful exercise. And I also, you've mentioned this as recovery, and the recovery spec is currently being still evolved in OCP, so it may be an opportunity to look at how to do things in alignment and increase reuse.
I think the one thing I'm aware that might be a little different for OCP is that the root of trust is running at the same time as other components are running. So it doesn't necessarily need a reset of the platform or a specific module to be able to start those recovery actions. Or maybe it does, I'm not sure. That'd be a great question if you know the answer to it. The small slice Tcg focused on was, early boot as a safe place to stand for that resilience engine. I think, we've got more work to do around a runtime thing that's able to do recovery while a target's still running.
Yeah, I think it's in OCP we kind of it is the first thing that starts, and we kind of expect. So if you think of like Cerberus as an example of a root of trust for a platform, it holds everything in reset and starts, but then it stays alive. It doesn't lock itself, which is like in your next slide you're talking about the locking after you've finished the job. That's actually not what's happening in the, at least in Cerberus, which you could argue is OCP inspiration. Yeah, but what other things do you agree that we want to pursue some alignment here and try to map it? Do you see the opportunity?
I think there's a good opportunity. I think the other question is, if your secure boot process fails that you're using in OCP, do you restart the platform and do repairs, or do you try to repair and continue the boot process? It could be, even though you do have a root of trust that's able to run at the same time as other things, you want to do a restart to do those recovery actions so you can have kind of a clean system to do the recovery actions on. I think that'd be a great place for more dialogue and exploration.
Yeah. Brett, you've been working on the recovery spec. What's your thoughts here?
Yeah, I've been trying to think through how this would map together. I do think the recovery spec could be a resilience engine. That does make sense to me. At this point, I don't think there's really been an effort to align the two. So I think that would be the next thing we would have to do, is figure out if the recovery spec could map into this model.
Yeah,
definitely it does make me, it gives me a lot to think about, and I was also taking notes through it.
Yeah.
There's another thing to consider too. When you just talked about secure boot, well, the hyperscalers, specifically Google, wants things to continue even if a secure boot fails, right? It get put in some kind of repair network. So it's almost as if something your resilience authority, I guess, here has to specify a policy of what to do, because it's not always the same.
Yeah, and to me that maps, and maybe this is just my mental model, but to me that maps well to, if you discover that things go wrong during boot, you can put some measurement in the PCR or in the TPM and signal to the outside world that, hey, this system is not to be trusted. And that's where the server TPM platform attestation actually comes to play. At least that's like the flow I have in mind. So if the system boots but it's not healthy, the TPM is the way to report that out and say, don't trust me.
Yeah, you could certainly use that too. If you know there's a patch you want to have installed, the TPM measurements would reflect that patch hadn't been installed. Then you could, after that, initiate a recovery process too. So, obviously putting measurements in about bad things is possible, but more likely case may be measurements about things that are older than you'd like them to be.
Yeah. I think to me, another comment that triggered my, made me write down a comment is about the TPM for the BMC. And how would that map to the OCP model where the BMC protects the BMC firmware? Like, how do we rationalize the two approaches here, like the BMC controlled by an ROT and firmware being measured by the ROT, or the PMC reporting out to the TPM and works more like a regular CPU. That would be another interesting angle to explore.
Yeah, certainly. I think there are some opportunity to explore there. I shared what Tcg Server Group is thinking currently and the path it is taking. I believe the path Server Group taking could easily fit into OCP's approach, but there may be some corner cases that we all probably need to have more discussion and get some alignment.
Yeah. Any other questions, Kate? Anything from the audience?
Nope, I don't see any other questions here. And I know we have about 5 minutes left. However, there is a little over an hour break next. So if you guys want to continue discussing, feel free. If not, we can continue with the break. I did see a couple of folks join on the line. So if you'd like to unmute yourself and ask the speakers a question, please feel free to do so.
Anyone? So I'll ask a question.
So,
do we? Sorry, go ahead.
Oh, no, I was just gonna bring up one of the ones that you have on here, Yigal. What about this interop question?
That was my question.
I think this is something I think a lot of people have asked that, and how do we move forward on getting all of these pieces and parts to play together?
I would say we need to, and the question is there an interop framework that already exists either maybe in Tcg or in Dmtf that we can hook into, or do we need to organize something at the OCP level? I don't know, but I definitely agree with you that we need one.
Yeah, I mean, there's an event, right, that we actually do the interoperability testing, but I think before that, we need to encourage those tests to be written. And there is a mechanism in OCP to do that as a contribution. So if a company wanted to satisfy their contribution requirements, that would be a good one.
To provide what, like test framework?
Test code, yeah, test code, test framework, either one. Code, I would think, would be best.
Maybe we need to do a test code for attestation interop.
I think we do.
Yeah.
Yeah.
I think having a reference implementation would do a lot, especially if it's an open source. So like if you're working on the BMC, getting code into OpenBMC would be great, because then like once it's working correctly, everyone gets the working version for free. And that will reduce the burden of doing interoperability testing by a lot.
Yeah. Absolutely agree with you.
Yeah,
I don't know if you've seen, but Chameleon announced yesterday that we plan to implement the ROT based on OCP specs, and we plan to contribute back the attestation code. So that would be a first step, but I think we need something bigger. Yeah.
That's great.
Wonderful.
Yep.
Tcg has recently made an attestation work group with sort of an intent to do more coordination with other industry groups. So, I think certainly raising this question to that work group in Tcg might be helpful, and we'll see what collaboration we could get going too.
Yeah. Is there a Tcg interop event that we can hook into?
No, not at this time. I think they've done interop events around storage or trusted network connections, but I don't think they've done it around attestation, but that's certainly something to think about in the future.
Okay, cool. Any other questions from anyone? Okay, so
I had a question.
Yeah.
This is Raghu from NVIDIA. So one of the things is, a lot of these attestation protocols so far have been focused mostly on the device side. And it seems like the other end of it, the verifier aspect of it, whether it's remote or whether it's the platform root of trust, is not really, or at least I'm not seeing as much standardization going on with that respect, right? So is that something that these three forums can collaborate on and start to standardize and put some more effort into?
One comment, OCP has one of its directions, and our meaning the OCP security team marching orders are to work on the common platform for the security side of a common platform. So that would certainly fall within this domain. We haven't started it yet, though.
Yeah, I agree. I think most of the specs right now are written from the point of view of the tester device mostly, but there is some references to the verifier or the platform side. I think we would love to partner with anyone who wants to work on the attestation code and on both sides, because what especially like specifically at Chameleon, we are developing the verifier, the PIROT side. So we'd love to partner with anyone who wants to jointly develop this and contribute back to the community and help this whole ecosystem get a faster adoption.
Yeah, because the components, we have the device side, but right now the attestations will just fall on the floor, right? If there's nothing to catch them and verify them. So certainly that needs to be done, as well as the format of the measurement lists, right? And
correct.
We'll talk about that later in another session today. In the measurement and attestation section, Monty Weissman will talk about what TCG is doing for the reference manifests.
Okay. Any other questions from the audience? Okay, so let's wrap it up. I think we're out of time anyway. For anyone still listening, we would like to encourage you to review the V1 of the specs, start implementing, provide feedback. We've released V1s, but obviously V1 is the beginning of the journey. So we would love to get feedback and also help shape the next round of spec. There are some specs still in the works and being developed. And I'm sure there will be a V1.1 for attestation. So we would like to encourage everyone in the community who feels they can contribute to come join us. I'd like to thank all of the speakers here for your time and preparation and insights. So thank you very much. And with that, I think we are